Okay. Hello. So now I think we were done going over the Grignard stuff. Did anyone have any questions before we go on to protecting groups? I'll give it a moment in case you want to like type a question or anything. Are you going to finish the exam review? Yes. So the exam review part 1 is currently being processed. I don't know if that means you can see it or not because it allows me to click on it. Part 2 and 3 are in the works of being uploaded. This session is going to be uploaded. This morning's session is going to be uploaded. I'm just trying to not overwhelm it all at once. So it's taking a little bit of time, but everything will be uploaded by the end of the day, the latest. And as far as finishing the exam review, if you were there yesterday, which I know most of you guys were, you saw that it kind of went a little bit unhinged and insane at the end there. So we promised to like record some stuff that wasn't there at the end and then post it for you. So Katrina recorded a couple questions, like answering a couple practice problems. I'm going to record a couple things, and those will also be posted by tonight. And I'll add that to part 3. Or I might just make it a new one. I'm not 100% sure. Yes. Whatever is like most convenient for uploading it to YouTube. Okay, cool. And then I see part 1, someone said, so that's awesome. Part 2 is loading right now. It is being like a snail for some of them, and it's going super fast for some of them. So I don't know what's going on with YouTube right now, but a lot of the stuff that I uploaded prior to today is like out of order, so I apologize for that, but everything has like the dates in the name, so it shouldn't be too hard to figure out what's going on. But yeah, I'm just like talking too much at this point. This session is going to be uploaded, yes. I'm going to try and upload it in order though, so I'm going to upload the exam review and finish with that, and then upload this morning's session, and then upload this session. And yes, they are going to be posted to the YouTube channel. Yeah, so most of my tutoring sessions are in person, so they don't get recorded, unfortunately, because they're in, like, it's not like my SI session where I get a computer. But all the virtual ones that I do, I will upload for you guys, because I know that they can be super useful. But again, if anyone ever has an issue, like if you're in the tutoring session and you kind of are like, oh, I don't want you to record it for whatever reason, or I don't want you to say my name or anything, absolutely, please feel free to tell me that, because your privacy is very important to me. All right. So now that I've been talking forever, just kidding, I lied. Okay, yeah, so that is completely valid. Do not overwhelm yourself. You're going to do great. And protecting groups, we're going to talk about it now, and it'll be uploaded so you can watch it whenever. So I hope the rest of your day is better than your morning. Okay. So now, yes, what's up?
Oh, can you do another Grignard reaction example?
Yes. Okay, one moment before I forget. So I'm just gonna write protecting groups, just so I don't forget to go back to it. And then I'm gonna go to the actual practice problem set to find a Grignard reaction problem that like is actually gonna be on there. And bye bye, Leah. Oh, she already left. Okay, so let's go to the is this it? Yes, it is. Okay. So the 11 and 12 questions are kind of overwhelming because they have a lot of stuff that we have not covered yet. So if it's something that we haven't seen before, don't worry about it, which is easier said than done. But let me find a Grignard reaction. Don't look at the answer. Okay. Ta-da. So this is a Grignard reaction kind of problem that you'll see on the exam. So I don't know if I want to redraw. Yeah, I guess I'll go ahead and redraw it for you. So I always like to count my carbons. 1, 2, 3, 4. So we have a 4 carbon chain. On carbon 3, we have a bromine. And we immediately know this is a Grignard reaction because that's the only time we see magnesium, right? And the fact that we start with an alkyl halide and have magnesium as our reagent means that we are making the reagent in the first step, and then we're doing some kind of reaction. So we know that magnesium comes in here, and we end up getting this. So this is going to be N, which is that. And now N has only a D2O to react with. I'll go like that. So all D2O is like H2O, except he uses deuterium instead of oxygen, just so he's like kind of sneaky and he can like figure out that you know what you're talking about and you're just not guessing. So what's going to happen is we have this minus charge, all we have is water, so this is going to go ahead and steal a deuterium, and we're going to get that. Oops. That's all that happens. So we want to find the answer that replaces essentially this bromine with a deuterium. And this is one of those like very few things that I would suggest not redrawing if you understand the concept and like what's going on, because you just have to find the answer choice that gets rid of bromine and adds a deuterium in its spot, which would be answer choice B. Any questions about that? I know I said a lot of things in not a lot of time. So how do we feel?
Rosemary?
Yes.
So the N is a nitrogen, right? That N is a nitrogen.
No. So N is just like, N and O are just saying like, oh, this is a product that I'm not going to tell you. So like he could have said A and B, or he could have said 1 and 2. So those aren't like atoms. It's just saying like, oh, this is an intermediate. We're going to call the intermediate N, and we're going to call the final product O. So this is the intermediate N, and this is the final product O. And then Joe said, feels good, made sense. I freaking love to hear it. Did that make sense, Anthony, with like the N and the O and what that means?
It does. So when can magnesium attack the carbon? Where is it attacking?
So yes, it's kind of attacking the carbon, and it's essentially just like sliding in here and it's taking away the bromine. So we can almost think of it like an SN2 where it gets rid of a leaving group, but not really. So anytime, or what you asked is like, when could this not happen? So let's say we had an OH here, then it would not occur. So anytime we have an acidic hydrogen here, or in our reagent, like whatever we're going to react it with, then it would not be a Grignard reaction. It would just be like acid-base. So kind of like this last step, I would consider this as not really being a Grignard reaction, because this is an acidic hydrogen. All we're doing is acting like a base and stealing a hydrogen. Whereas if I reacted that with some carbonyl, it would act like a nucleophile and it would actually attack this carbon and attach itself to it. So does that distinction kind of make sense? I know it's a weird.
Yes, it does.
Yes? Okay. Yay! Let's see if I can find another Grignard reaction. No. 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 This is unfortunate. Yeah, I don't think he has any. Oh, okay, here we go. Which synthesis of a Grignard reagent would fail to occur as written? So, oh, hold on. So, the little chart from Monday when you said Grignard reaction can't occur when there's a triple bond, acidic hydrogen, carboxylic acid, or heteroatom. That's when it can't occur. Exactly. So, if we flip back to this right quick, whenever we have an acidic hydrogen, the Grignard reaction won't occur. And this is what I mean by acidic hydrogen. So if any of these are on your, are in any part of your reaction, it will not occur because of the Grignard reacting as a base rather than as a nucleophile. You're welcome. So let's slam back here. Okay. So, which of the following will fail to occur as written? And I just told you that it will fail to occur when we have an acidic hydrogen. So we're going to find which one of these has an acidic hydrogen. So I'm going to zoom in here. It's very important that you guys practice your functional groups. So when I look at this, I see that this is an ether. We have a CH3O, CH2, CH2, Br. So does this have an acidic hydrogen?
Yes, because there's a heteroatom.
Okay, so there is a heteroatom, but the hydrogen has to be directly attached to the heteroatom for it to be considered acidic. So something like this. So actually, in this case, even though there is a heteroatom present, it's just a distractor because this isn't attached to the heteroatom. So this would not be acidic. But like Joe said, this functional group is a carboxylic acid. And so if I draw it out, which I'll do over here. Sorry if I'm moving the screen a lot. So it would be OH, O, CH2, CH2, Br. So now there is a heteroatom and your hydrogen is attached to it. And it's a carboxylic acid. So this is acidic. So that will not happen. So C will fail to occur as written because it has an acidic hydrogen. The rest of these guys are either just carbon chains or the hydrogen is not on the heteroatom. Does that make a little bit more sense?
So like you said, the hydrogen has to be like bonded to the oxygen in order for it to be like a heteroatom.
Yeah, exactly. Well, okay, so it's going to be a heteroatom regardless, but in order to be an acidic hydrogen, it has to be directly attached to the heteroatom. I think you know what you meant. I just want to make sure, like, you know, like the vocab words kind of. Cool? Okay, cool. Let's see if there's any more. Nope, that's it. Okay. So, would you guys like to go back to protecting groups, or would you like to work on something else?
Spectrum.
I heard that you said something, but I don't know what you said.
I said NMR spectrum.
Okay, so kind of like, oopsie, stop it, chill. Like the practice problems, or you want to talk about like chemical shift?
Practice problems.
Okay, yeah. That's what I figured, but I thought I'd ask. Oh, and we're all on the same page. Swaggy. All right, so I really like this example because he will have something similar to this. And the absolute first thing I notice is, whoa, this is all the way at 12. And that doesn't happen super often, but we know that 12 equals carboxylic acid. So here it's not the most helpful part of the spectrum because 3 out of the 4 answer choices are carboxylic acids, but on the exam, that'll be usually a very clear indicator of what the answer is. But in this case, CHO is an aldehyde. Aldehydes would be around 9 ppm, so this one is wrong. All right, next thing I notice is that there are 4 signals. And while we're here, let's just write out the regions. So alkyl, this is going to be aromatic. And we already talked about the last one, that's the carbonyl region. So, something I want you guys to notice, on your exam, I hope there won't be questions where it's kind of ambiguous like this, but if you see here, there's 5 hydrogens in the aromatic region, and it's a whole bunch of messy stuff, right? So what this basically means is that we have a benzene ring, and that benzene ring has 1 substituent on it. We don't know what it is, but it's something. And all 5 of these hydrogens left over are counting as 1 signal. So that doesn't necessarily mean that they are all symmetrical to one another. It could just mean that this is not a very good NMR machine, and this is all clumped up together. So all of these are showing up as 1, even though they would be different signals. Does that sort of kind of make sense? I know it's confusing because they teach you like what it would be like ideally, and then they ask you with these really crappy pictures. So yes, I can definitely repeat that. So basically, if you see a giant like clump like this with like 4 or 5 or even 6 as the integration, sorry, that took a second. What this is essentially telling you is that, sorry, I forgot an important part. If you see a big clump specifically in the aromatic region, what that's essentially telling you is that you have a benzene ring, and that benzene ring has multiple different signals on it, but this NMR machine sucks. So all of them are going to be clumped together as 1 signal. So, for example, in this case, we have 1, 2, 3, 4, 5 hydrogens. And in an ideal spectrum, we could see that there is symmetry here in the ring. So these 2 would be the same. These 2 would be the same. And this one would be unique. However, this spectrum is telling you that this crappy NMR machine is seeing all 5 of these signals as 1 gigantic lump. and not as multiple different signals. Does that make a little bit more sense? Okay, cool. I am going to disappear for 1 second. I will be right back. Okay, hello, sorry about that. Someone came over to my house, and so my dog was like losing his mind. We're fine. Okay, so back to this. You guys said yes, it kind of does make sense, so it do be like that. So let's continue, right? Now that we talked about like the whole aromatic thing, we're gonna go through and we're gonna see which one of these aromatic rings has 5 hydrogens on it. This one only has 4, so this one is out. This one is kind of like a decoy to trick you. That's not a benzene. So this is a decoy, not the right answer. Here, it is a benzene, and we have 1, 2, 3, 4, 5. So that could be the correct answer. So now we're between 2 answer choices. Does it make sense how I got this far? Okay, we got 1 yes. So unless I get a no, we're going to continue. So now at this point, we exhausted this. So we never actually looked yet at the 4 signals because we got distracted by other big things. So let's see which one has 4 signals. This, again, is all going to count as one big signal. So I'm going to count this whole thing as 1. And then we're going to say 2, 3, 4. So that works. Also, I hate how ugly this looks, so I'm just going to highlight one of them. And let's go down here, highlight one of these, 2, 3, 4. Okay, both of them have 4 signals, so we have to keep going. All right. So these 2 signals are both in the alkyl region, and they're both 2H. So we're going to find which one of these answer choices has 2 more signals with 2H integration. This first one, 2H, and 2H. So this looks like the right answer, but let's just double check. If we go down here, 1H and 3H. So this one has to be wrong, and A is the correct answer. And let me zoom out so you can look at the whole thing. This one was one of the complicated ones, and it has this whole like benzene thing, so it's annoying. But does it make sense how I got to the final answer?
So if there is no double bonds inside the ring, we automatically take it out.
Yeah, exactly. So for aromatic, so far we have not learned about aromaticity. We'll do that in chapter 14. So the only aromatic compound you're expected to know is benzene. If it looks like this, oh wow, not if it looks like that. If it looks like this and there's no double bonds in it, this is not a benzene, it's just cyclohexane. And sometimes he'll try to trick you by putting this in there and putting a peak in the aromatic region like you saw here, but this doesn't have double bonds, so it's not a benzene. All right, so let's do another one. I think I did this one in SI, but You guys let me know. Do you want to cover it or not? Because I don't remember. Everything blends together.
You do this one in Tutoring.
Okay. Okay, so Joe said do it again. So unless you have any complaints, we can just go through it right quick. So first thing I see is that everything's in the alkyl region. Cool. I see that I have 3 signals. And the biggest thing that jumps out at me automatically is this 9. Right? So I'm going to go and I'm going to find out which one of these choices has 3 signals. And then the second thing I'm going to look at is the 9 integration. So we have a little bit of internal symmetry on this first one. Those two are identical. So we have 1, 2, 3, 4, 5 signals. That's way too many. In the second one, we have symmetry again. So we have 1, no hydrogen here. 2, 3, 4, 5 signals. Again, way too many. If we go down to this one, we're going to split it in half right here because of symmetry. And we have 1, 2, 3 signals. None here because there's no hydrogens. So, okay, this one has 3. In this next one, symmetry, 1 signal, none here because of triple bond, none here because of triple bond, 2, 3. Okay, this could be it. And last but not least, again, we have symmetry here. We have 1, 2, 3, and we do have a hydrogen here. So this makes 4. Too many. Kick that one out. So just by the number of signals we have, we've kicked out 3 of the answer choices. So we're stuck with these 2. And we see that there's a 9 integration here. So let's figure out which of these 2 has a signal with an integration of 9. Here, we see that there's symmetry, but the highest number for integration that we have is 6. So we can kick that one out. Here, we have an integration of 9. So this one, I don't know why I did it in red because now it just looks sloppy, but hopefully you can still see it. That has an integration of 9, so that would be the correct answer. Let me zoom out so you can see the whole thing. Any questions? I know we did it kind of fast. Okay. Also, I am going to have to leave around like 5 minutes early, so around 3:45-ish. So I'm just letting you guys know now. We have about like 10 minutes left. So if you have any other questions or any other things that you want to cover, please let me know. If not, we can just continue doing these practice problems. I don't like this one, so we're going to skip this one. We can do this one. This one's fun.
Rosemary?
Yes, what's up?
So, for the test, we're expected to know mass spectrometry, graders reaction, and protecting groups.
Okay, mass spec, I think you said Grignard reaction, and what was the last one?
Yeah, Grignard reaction and protecting groups.
Yes. So let me show you the list of stuff you're expected to know. Nope. Share my screen. And then I'm almost positive you're both in Dr. West's class. So that's a yes for mass spec. But if you are in Dr. Roche's class, you will not be asked about mass spec. At least that's what I was told. So this is the list of concepts. Some of these are named super weird. Like he just says it super weird. So if there's anything you have a question on, like what does that mean, you can ask me. I don't know why he has mass spectrometry and the mass spectrum is two different concepts. That just means mass spec. And the last one, conversions of alcohols into alkyl halides, that is just part of protecting groups. And alcohols from reactions of carbonyls, that just means reduction reactions. So I don't know why that's two different things, but whatever. Any questions about this, or should we go back to the practice problems?
Could you do a reduction? What is that?
Yes.
Alcohols from reduction.
Yes, so alcohols from reduction reactions just means... I'll find a question. I know there is one in here that I like, so... Okay, don't look at the answer. This is one of the questions that I actually like. So it's asking you for the product, and again, A and B. It's kind of what I talked about with nitrogen and oxygen. So the reason you know automatically this is a reduction reaction is because we have NABD4. And so this is just NABH4 with a deuterium substituted. So it'll react exactly the same way. And we know that this is a weak reducing agent. So weak reducing agents can only reduce which group? Group 1 or group 2? And if you guys don't remember, that's fine. But
does it reduce? Okay.
Remember, group 1 is aldehydes and ketones. Group 2 is carboxylic acids and esters. So which one do you think it will reduce?
Carbonyl.
You're cutting out, so I know you're saying something, but I can't hear you. So I'm just going to say it's group 1, which is aldehydes and ketones. And the reason it's only going to reduce aldehydes and ketones is because they are more reactive, so they don't require a strong reagent, whereas carboxylic acids and esters are less reactive, so they require a stronger reagent. The reason I even bring this up is because here he gave you a ketone, but he could give you something like this. So it's almost the exact same problem, but now we have an ester, and so the answer would be no reaction. So just watch out for that. So this plus a weak reagent would be no reaction. All right, so that segue aside. If we have a ketone plus a weak reagent, we are going to make an alcohol. What kind? Are we going to make a primary or a secondary alcohol? What do we think? Don't know? That is completely fine. All right, so D minus is the reducing species, just like H minus would be. So we're going to attack here, right? And we're going to go from this to this. No worries. And then we have H2O. So this minus charge is going to steal a hydrogen. And we get... So we're looking for the answer that has an OH and a D on that middle carbon. So this one has OD, wrong. OH and a deuterium, okay, that looks good. Deuterium, OD, wrong. And OH, H, no deuterium, that's wrong. This one, what the heck is going on? We have a carbonyl and a deuterium at the end, wrong. So the only one that makes sense is C. Ta-da. And there's one other reduction question that I want to show you, because he can either ask you one like this, or he can ask you one in the format of the one I'm about to show you. But if you have any questions about this one, ask me before we move on. Sorry, the coffee I drank is just now kicking in, so I'm just like...
Rosemary?
Yes.
So for C, it says OD, but I know on the final problem we have
Oh, I'm so
HO.
sorry. I said the right thing, but I highlighted the wrong one. So yes, because this was an OD, we crossed this one out. Because this one was an OH, that's why it's the correct answer. Thank you for pointing that out. Alrighty. So yes.
Rosemary,
Yes.
for this one we have to memorize like a chart, like we used to do with SN2 and SN1 kind of thing.
Kind of. So this is what I would memorize for reductions, right? Right here. Reducing agents, we have LiAlH4, which I'll write here, strong. NABH4, weak. And this isn't how your textbook does it, but this is how I do it just because it helps me and a lot of students. So group 1 is aldehydes and ketones. Those are more reactive, so they can only react... they can go ahead and react with any reagents. They don't have to have specificity. Group 2 is carboxylic acids and esters. They have leaving groups and they're less reactive, so they only react with the stronger reagent, which is LiAlH4. And we also know that aldehydes reacted with a reagent will be a primary alcohol. A ketone reacting with either reagent will give you a secondary alcohol. And then both carboxylic acids and esters, when they're reacted with lithium aluminum hydride, will form primary alcohols. So if you memorize/know this page, you should be good for any kind of reduction question. Does that answer your question?
Yes, thank you.
You are very welcome. All right, right quick. I'll leave it up if you need it for one more second, and then we can... Okay. I know this problem exists. Okay, cool. It's right here. Don't look at the answer. Okay. So select the following, the correct reagents for the following reaction. Alrighty. So we're gonna go through and look at all the functional groups. Here we have a ketone. And here we have an ester. And if you don't see it, draw it out. That's what I always do. I can't see it in condensed formula. But I do recommend that for a couple of these, you do know what the condensed formula looks like. So if it looks like O2 and then some kind of carbon chain, that is an ester. If it's O2H, that's a carboxylic acid. If it looks like this, it's a ketone, etc. All right. So now in the final product, we see that this is still an ester. I lied. It's not an ester. I am going to draw it out. 1, 2, 3, 4, 5. OH. OH. All right, so the ester turned into an alcohol and the ketone turned into an alcohol. So whatever reagent we used, we reduced both group 1 and group 2. So we know we're looking for a strong reducing agent because this requires a strong reagent. All right, so this one is just kind of there to trick you. That's an Orga-1 reagent, just ignore it. And then between LiAlH4 and NaBH4, which one is the stronger reagent? A. So A would be the correct answer. I feel like I stuttered a lot through this one, so did it make sense? Any questions? I will leave it up in case you have any questions. If not, I am going to wrap it up there for today. So please enjoy the rest of your day. These will be uploaded hopefully sooner than later, but for sure by the end of the day. If you have any questions, please feel free to email me. You're going to do amazing on your exam. And yeah, I will see you when I see you. I'll stay on for another minute or so, but I am going to end the recording in case you have any questions. So adios.